of this. Today, we are going to learn how to identify probable faults, causes and remedies in the given faulty SMPS. Serial number 1. False. SMPS dead, fuse blown. Causes: shorted switching transistor or semiconductors, power cord defective or switch, open fusible resistor, other bad parts. Actual cause of failure may be power surge, brownout, lightning strikes, random failure, or primary side electrolytic capacitors with greatly reduced capacity or entirely open. Remedy: test the switching transistor or semiconductor switch. If it fails, replace it. If the semiconductor switch is good, check and replace the primary diodes. Replace the fusible resistor. Testing a transistor using multimeter. Step number 1. Identify the terminals of NPN transistor like emitter, base and collector from the datasheet. Step number 2. Set the multimeter in diode test position. Step 3. Place the red and black probe of multimeter on the base and emitter terminal of the transistor respectively, that is, forward bias. The drop should be around 0.6 to 0.7 volts in the forward bias direction. Step 4. Reverse the multimeter leads red and black probes on emitter and base terminals of transistor respectively, that is, reverse bias. The multimeter should read OL, open circuit, or a very high resistance in the reverse bias direction. Step 5. Place the red and black probe of multimeter on the base and collector terminal of transistor respectively, that is, forward bias. The drop should be around 0.6 to 0.7 volts in forward bias direction. Step 6. Reverse the multimeter leads red and black probes on base and collector terminals of transistor respectively, that is, reverse bias. The multimeter should read OL, open circuit, or a very high resistance in the reverse bias direction. Serial number 2. False. Supply dead, fuse not blown. Causes: bad startup circuit, open startup resistors or open fusible resistors due to shorted semiconductors, bad controller components. Remedy: test the switching transistor or semiconductor switch. If it fails, replace it. Replace the fusible resistor. Replacing fusible resistor. Use a soldering iron to heat the solder joints connecting the fusible resistor to the circuit board. Once the solder is melted, remove the fusible resistor from the PCB board. Place the new fusible resistor into the same position on the circuit board. Serial number 3. False. Supply mostly dead or takes a long time to come alive. Causes: bad electrolytic capacitors. Visually inspect for capacitors with bulging tops or that have leaked. Remedy: if any one bad capacitors are found, replace all electrolytic capacitors. Replacing electrolytic capacitor. When a capacitor becomes faulty or deteriorates, it can bulge or swell, indicating a potential problem. Use a soldering iron to heat the solder joints connecting the capacitor leads to the circuit board and then remove the bulging capacitor and replace it with a good one with same value. Serial number 4. False. More ripple at the line frequency 50 by 60 Hz or twice the line frequency 100 by 120 Hz. Causes: dried up main filter capacitors on rectified AC input. Remedy: check the filter capacitor and replace it. Filter capacitors are commonly placed near the output stage of the SMPS circuitry. They are often located close to the rectifier diodes or output switching transistors. Use soldering iron to remove the faulty capacitor and replace it with good one. Number 5. No output supply and 300 volt persists in the filter capacitor after switching off the supply. Causes: switching transistor or semiconductor switch short and fusible resistor or starting resistor open. Remedy: test the switching transistor or semiconductor switch. If it fails, replace it. Number 6. SMPS output is low. Causes. If SMPS gives low voltage output, then the fault is mostly in the error amplifier and oscillator stage. Output loading may also affect the output voltage sometime. Remedy. Measure voltages and compare them with normal voltage given in the circuit diagram. Probable paths may be faulty Zener diode in the error amp, faulty control circuit paths, transistor, IC, optocoupler faulty. Testing the Zener diode. Number 1. Switch your multimeter to resistance mode. Number 2. Determine the terminal of the Zener diode. The cathode is typically marked with a band or line, and the other end will be the anode. Number 3. Place the multimeter probes on the terminals, red and black probes on the anode and cathode terminals respectively, that is, forward bias. If the diode is healthy, the multimeter will display a few hundred ohms. Number 4. Now place the red and black probes of the multimeter on the cathode and anode terminals respectively, that is, reverse bias. If the diode is healthy, the multimeter will display a very high resistance or no reading or OL, open loop. Number 7. False. SMPS output is high. Causes. If SMPS output is high, first shutdown set. Fault in the error amplifier, IC, oscillator section of SMPS. Remedy. Check fault either in switch off condition or by giving input supply through a variac or low voltage transformer. Disconnect TV or computer other sections by disconnecting base or output transistor. Never keep on in this fault. It may damage other parts also. Check for error amp circuit, Zener diode, optocoupler, filters on error amplifier line, transistor, IC, oscillator. Replace the faulty components. Number 8. Combusted coil. Causes. A winding coil is present on the board which sometimes gets burned due to excessive flow of current. Remedy. This problem can be identified easily by the smell, or you can identify through the burnt marks located on the external section of the winding coil. It may be possible that internal loop is damaged. Recap. In this video, we have discussed how to identify probable faults, causes and remedies in the given faulty SMPS. Thank you for watching. Hi everyone. In today's video, let us learn how to measure or monitor at major test points of computer SMPS unit. Objectives. At the end of this video, you will be able to: Number 1. Prepare the computer SMPS unit for voltage measurements. Number 2. Measure or monitor voltages at various test points of the SMPS unit. Let us collect the tools and equipment required to do this practical. Computer SMPS working 1 number. Trainees toolkit 1 set. Digital multimeter with probes 1 number. Aids. Chart showing various voltages of connects in SMPS unit of PC 1 number. Computer power code 1 number. Hookup wire as required. First, let us carry out the safety precautions before doing this practical. Number 1. Keep the place dry and clean. Number 2. Make sure you conduct this test on a table with yourself standing on a rubber mat or any insulated material to avoid static electricity destroying the computer peripherals. Procedure. Task 1. Preparation of computer SMPS unit for voltage measurements. Step 1. Remove the SMPS from the computer cabinet by follow the procedure. 1. Open the computer cabinet cover by removing the door screws. 2. Identify the location of wires with color codes coming out of SMPS unit. 3. Note down the connections of SMPS going to various sections of motherboard and other devices inside the CPU. Put tags with label for each connector. 4. Remove or unplug the connectors from HDD, DVD, fan and motherboard carefully. 5. Unscrew the fixing screws and remove the SMPS unit from the CPU cabinet and open it. Step 2. Identify the green color wire power good signal test point from the bunch of wires on the 24-pin Molex connector as shown. Step 3. Use a piece of hookup wire, bend it as U-shape. Connect it across the green and black wire terminals as shown. Step 4. Connect the power cord to the SMPS unit and switch on power. Step 5. Observe the fan is running to confirm the working of SMPS unit. Step 6. Remove the hookup wire and reinsert if the fan is not rotating. Task 2. Measurement or monitoring voltages at various test points. Step 1. Set your multimeter to the AC voltage range appropriate for the voltage level you expect to measure. For standard household sockets, select a range higher than 240 volts. Step 2. Insert the red test lead into the voltage resistance milliamps port for measuring voltage. Insert the black test lead, common or negative lead, into a common port on your multimeter. Step 3. Plug the SMPS input power cord into the 3-pin socket of the 240 volt AC power supply and then turn on the switch. Step 4. Turn on your multimeter and hold the test lead securely in place of the power cord. Ensure that the probes are making good contact with the metal contacts inside the socket. Read and record the voltage displayed on the multimeter screen in the tabulation. Serial number 1. Parameter to measure phase to neutral. Voltage AC 230 volt. Remarks. 2. Phase to earth 230 volt. 3. Neutral to earth 5 volt. Step 5. Switch off supply and plug the mains cord into the SMPS unit and select the P4 power cable connector used for CPU cooler fan. Task 3. Let us discuss the different color codes used in SMPS. Using colored wire helps ensure that the correct connections are made during installation or maintenance, reducing the risk of electrical hazards such as short circuits or incorrect voltage connections. Serial number 1. Color red. Description: it is used to provide the stated voltage. 2. Yellow. It is used for motor running. 3. White and blue. It is used for backward compatibility. 4. Black. It is used for grounding purposes. 5. Orange. It is used to provide the stated voltage. 6. Green. It is used for power supply in ATX, Advanced Technology Extended. 7. Gray. It is used for power good, self-test, OK, signal in ATX. 8. Purple. It is used to provide plus 5 volts whenever the PSU is powered, even when the green wire is not connected to the ground. Stand by. Let us look at the voltage level of different colors in different SMPS units. Serial number 1. Colors. Red. Advanced Technology plus 5 volts. Advanced Technology Extended plus 5 volt. Balanced Technology Extended plus 5 volt. Number 2. Yellow. Plus 12 volt. Plus 12 volt. Plus 12 volt. Number 3. Blue. Minus 12 volt. Minus 12 volt. Minus 12 volt. Number 4. White. Minus 5 volt. Minus 5 volt. Minus 5 volt. Number 5. Black. 0 volt. 0 volt. 0 volt. Number 6. Orange. Plus 5 volt. Plus 3.3 volt. Plus 3.3 volt. 7. Green. plus 5 volt, plus 5 volt. 8. Gray, plus 5 volt, plus 5 volt. 9. Purple, plus 5 volt, plus 5 volt. Task 4. Let us discuss the pin description of the 24-pin power cable connector and also measure and record the output voltage in the tabulation. Step 1. Set your multimeter to the DC voltage range appropriate for the output voltage level you expect to measure in SMPS unit. Step 2. Switch on SMPS supply and measure the DC voltage across the 24-pin power connector. Step 3. Turn on your multimeter and set it to the DC voltage measurement mode. Select a voltage range appropriate for the expected voltage levels into your system. Step 4. Locate the ground reference point in the connector. In most cases, ground pins are labeled as GND or COM, common. You can also identify the ground by its OV potential with respect to other pins. Step 5. Take the black probe, negative, and connect it to the ground pin. Then, take the red probe, positive, and touch it to the pin you want to measure the voltage of. Step 6. Refer to the chart showing voltages at various test points on power cable connector and record the observations. This is the connector that goes to the motherboard to provide it with power. This connector is the largest of all the connectors. Serial number 1. Wire color, orange. Description, plus 3.3 VDC. Measured voltage. Number 2. Orange, plus 3.3 VDC. 3. Black. Ground. 4. Red, plus 5 VDC. 5. Black. Ground. 6. Red, plus 5 VDC. 7. Black. Ground. 8. Gray, power good. 9. Purple, plus 5 VDC standby. 10. Yellow, plus 12 VDC. 11. Yellow, plus 12 VDC. 12. Orange, plus 3.3 VDC. 13. Orange, plus 3.3 VDC. 14. Blue, minus 12 VDC. 15. Black. Ground. 16. Green. Power supply on. 17. Black. Ground. 18. Black. Ground. 19. Black. Ground. 20. White. 5 VDC. Optional. Removed in ATX 12 volt V 2.01. 21. Red, plus 5 VDC. 22. Red, plus 5 VDC. 23. Red, plus 5 VDC. 24. Black. Ground. Recap. In this video, we have learned to number 1. Prepare of a computer SMPS unit for voltage measurements. Number 2. Measure or monitor of voltages at various test points. Number 3. Different color codes used in SMPS. Number 4. Pin description of the 24-pin power cable connector. In the last video, we have learned to number 1. Prepare a computer SMPS unit for voltage measurements. Number 2. Measure or monitor voltages at various test points. Number 3. Different color codes are used in SMPS. Number 4. Pin description of the 24-pin power cable connector. In continuation of this, in this video, we are going to learn about the number 1. Pin description of the P4 12-volt 4-pin power connector. Number 2. Pin description of a 4-pin Molex peripheral connector. Number 3. Pin description of 20-pin power connector. Task 1. Let us look at the pin description of the P4 12-volt 4-pin power connector, also called the P4 power connector, a second connector that goes to the motherboard in addition to the main 24-pin connector to supply dedicated power for the compressor. Step 1. Turn on your multimeter and set it to the DC voltage measurement mode. Select a voltage range appropriate for the expected voltage levels in your system. Step 2. Locate a ground reference point in the connector. In most cases, ground pins are labeled as GND or COM common. You can also identify the ground by its 0-volt potential with respect to other pins. Step 3. Take the black probe, negative, and connect it to the ground pin. Then take the red probe, positive, and touch it to the pin you want to measure the voltage of. Step 4. Switch on SMPS supply and measure the DC voltage across the P4 cable connector using multimeter and record the readings in tabulation. Serial number 1. Description: ground. Wire color: black. Measured voltage: 0. 2. Ground: black. 0. 3. Plus 12 VDC. Yellow: 12 volt. 4. Plus 12 VDC. Yellow: 12 volt. Task 2. 4-pin peripheral power connector. Number 1. This 4-pin peripheral power connector is also called Molex. Number 2. These are the smaller connectors that go to the various disk drives, cooling fans, and other smaller devices of the computer. Most of them have 4 wires, 2 black, 1 red, and 1 yellow. Number 3. Unlike the standard mains electrical wire color coding, each black wire is a ground. The red wire is plus 5 volt and the yellow is plus 12 volt. Number 4. Switch on SMPS supply and measure the DC voltage across the 4-pin peripheral power connector using multimeter in DC voltage mode and record the readings in tabulation. Serial number 1. Description: plus 12 VDC. Wire color: yellow. Measured voltage: plus 12 VDC. Number 2. COM: black. 0. Number 3. COM: black. 0. Number 4. Plus 5 VDC. Red. Plus 5 VDC. Task 3. Let us discuss the pin description on 20-pin power connector. Number 1. The pinout or pin description of a 20-pin power connector typically refers to the arrangement and function of each of the 20 pins within the connector. This type of connector is commonly found in computer power supplies, specifically in older ATX Advanced Technology Extended Power Supplies. Serial number 1. Wire color: orange. Description: plus 3.3 VDC. Measured voltage: 3.3 volt. Number 2. Orange. Plus 3.3 VDC. 3.3 volt. Number 3. Black. Ground: 0. 4. Red. Plus 5 VDC. 5 volt. 5. Black. Ground: 0. 6. Red. Plus 5 VDC. 5 volt. 7. Black. Ground: 0. 8. Gray. Power on. Power on. 9. Purple. Plus 5 VDC. Standby. 5 volt. 10. Yellow plus 12 VDC, 12 volt. 11. Orange plus 3.3 VDC, 3.3 volt. 12. Blue minus 12 VDC, minus 12 volt. 13. Black, ground, 0. 14. Green, power supply on. 15. Black, ground, 0. 16. Black, ground, 0. 17. Black, ground, 0. 18. White, 5 VDC, optional removed in ATX, 12 volt. V2.01, 5 volt. 19. Red plus 5 VDC, 5 volt. 20. Red plus 5 VDC, 5 volt. Recap. In this video, we have learnt on number 1. Pin description of the P4 12 volt 4-pin power connector. Number 2. Pin description of a 4-pin Molex peripheral connector. Number 3. Pin description of the 20-pin power connector. Thank you for watching. Hi everyone. In today's video, let us learn how to troubleshoot the fault in the given SMPS unit, rectify the defect and verify the output with load. Record your procedure followed for troubleshooting defects. Objectives. At the end of this video, you will be able to: number 1. Discharge the filter capacitor of the SMPS unit. Number 2. Identify the physical faulty component and replace it and test the output with load. Number 3. Identification of the short circuit fault using bulb. Let us collect the tools and equipment required to do this practical. Electrostatic discharge workbench, 1 number. Safety gloves, 1 set. Trainee's toolkit, 1 number. Digital multimeter with probes, 1 number. LCR meter. Inductance, L. Capacitance, C. And resistance, R, 1 number. 100 watt by 230 volt bulb with holder, 1 number. Wire round resistance, 1.8 kilo ohms or 2.2 kilo ohms by 10 watt, 1 number. First, let us carry out the safety precautions before doing this practical. Number 1. Keep the place dry and clean. Number 2. Make sure you conduct this test on a table with yourself standing on a rubber mat or any insulated material to avoid static electricity destroying the computer peripherals. Number 3. Note that some connections of the SMPS connectors contain a clip attached to it. Make sure to remove the clips before removing the connection. Task 1. Discharging the filter capacitor. Discharging the capacitor prevents any stored electricity energy from posing a risk of electric shock to personnel who may come into contact with the circuit. Capacitors can retain a dangerous voltage even after power is disconnected. Method 1. Discharge the capacitor using bulb method. Step 1. Make sure the power cord is removed from the SMPS to avoid electrical shock. Step 2. Dismantle the SMPS by referring to the procedure. Number 1. Open the computer cabinet cover by removing the door screws. Number 2. Identify the location of wires with color codes coming out of SMPS unit. Number 3. Note down the connections of SMPS going to various sections of motherboard and other devices inside the CPU. Put tags with label for each connector. Number 4. Remove or unplug the connectors from HDD, DVD, fan and motherboard carefully. Number 5. Unscrew the fixing screws and remove the SMPS unit from the CPU cabinet and open it. Step 3. Connect a 100 watt bulb wire across the leads of the capacitor as shown to discharge the filter capacitors. Connect one end of the bulb to one terminal of the capacitor and the other end to the opposite terminal. This forms a closed circuit through which the capacitor can discharge. Method 2. Discharge the capacitor using resistor. Step 1. Take a high wattage low ohms wire wound resistor with proper insulated lead. Use either a 1.8 kilo or a 2.2 kilo ohm 5 to 10 watt resistor to discharge the high voltage capacitor. Step 2. Connect one end of the resistor to one terminal of the capacitor and the other end to the opposite terminal. This forms a discharge path through which the stored energy in the capacitor can dissipate. Step 3. Once the voltage across the capacitor has decreased to a safe level, usually a few volts or less, the capacitor is considered fully discharged and it is safe to handle or work with. Task 2. Identification of the physical fault. Fuse blown in SMPS. Step 1. Take the dismantled SMPS as shown. Step 2. The boot from the SMPS cabinet is similar to as shown. Step 3. Disconnect the SMPS and make sure all electrolytic capacitors are discharged. Step 4. Remove the fuse from its holder as shown. Step 5. Look the fuse wire if there is a visible gap in the wire. Step 6. Start by visually inspecting the fuse. Look for signs of damage such as discoloration, melting, or a broken filament inside the fuse. Step 7. Look the fuse carefully. Any dark or metallic smear inside the glass. Step 8. If any above faults found in the fuse, then the fuse is blown and needs to be replaced. Step 9. If there is no physical fault observed in fuse, then use multimeter to check it. Step 10. Set a multimeter to the continuity setting. Turn on your multimeter and set it to the continuity mode. This mode is typically denoted by a symbol that looks like a sound wave. Step 11. Touch one probe to each end of the fuse. Ensure good contact between the probe tips and the metal ends of the fuse. Step 12. If the fuse is intact and has continuity, the multimeter will emit a continuous beep or display a low resistance value. This indicates that the fuse is good. Step 13. If the multimeter reading is OL, over limit, as shown, then the fuse is blown. If the fuse is blown, replace the fuse with one that is exactly having the same current rating. Step 14. Record the observations in table. Observed. Beep sound occurs in the multimeter. Condition. Good. Task 3. Identification of the short circuit fault using bulb. Step 1. Connect the 100 watt bulb across the fuse holder as shown. Step 2. Power on the SMPS unit. Step 3. The bulb will be initially glowing bright. Then for a good SMPS, bulb glowing turns off. SMPS is in good or working condition. If the bulb does not light up, there is likely no short circuit in the circuit and the circuit should be functioning normally. Step 4. The light bulb will glow bright even after you have waited for a couple of minutes as shown. Then it indicates there is problem in the SMPS. Immediately switch off the AC main. Discharge the big filter capacitor either by using a bulb or a resistor as we discussed in the previous task. Step 6. Record the observation in the table. Observed. Bulb glows brighter. Condition. Short circuit occurs in the circuit. Check for any damaged components, loose connections, or other issues that may be causing the short circuit. Recap. In this video, So far we have discussed how to number 1. Discharging the filter capacitor. Number 2. Identification of the physical fault, fuse blown in SMPS. Number 3. Identification of the short circuit fault using bulb. Thank you for watching. Hello friends, in the last video we learned how to number 1. Discharging the filter capacitor. Number 2. Identification of the physical fault, fuse blown in SMPS. Number 3. Identification of the short circuit fault using bulb. In continuation of this, today we are going to learn how to identification the fault in short circuited components using resistance method and isolation method. Identification of the short-circuited components. Connection of SMPS, the circuit for performing load test. Task 3. Identification the fault in short-circuited components using resistance method. Step 1. Set the digital multimeter in resistance mode. Step 2. Keep the red probe to the cold ground and black probe to each of the secondary diode. If any of the components shows same resistance reading, low readout on both polarities, then suspect that there is a problem in that component. If the multimeter shows different values on both polarities, then the component is good. Task 3. Identification the fault in short-circuited components by isolation method. Step 1. Identify the B+ line of the back or boost sections and break or disconnect the B+ line from the circuit as shown. Step 2. Connect the 100 watt bulb between the B+ line to cold ground. Step 3. Power on and verify the bulb glowing condition. Step 4. There are 5 possibilities that can be expected from the light bulb. The light bulb lit with a constant brightness and all of the output voltage measured normal at the secondary side. This indicates the SMPS is working fine and the cause of the power problem in the load side. It may be flyback transformer, yoke coils, etc. No light from the light bulb and no voltage measured at the output of the power supply. This indicates the problem is in the SMPS. The light bulb glows intermittently. This could indicate components failure in the power supply like bad filter, capacitor, current sense resistor, higher ohm, etc. Value would have been increased. The light bulb become extra bright and all the output voltages have increased. This indicates the problem is in the regulation circuit, like an open resistor in feedback circuit, bad opto-isolator IC faulty, TLC 431 IC, etc. The light bulb keeps cycling continuously on and off. This could indicate problem in the SMPS area, and it can also mean the opto-isolator IC is sending an error signal to the primary circuit of power supply through opto-isolator IC, causing the power supply to cycle. Task 4. Identification of the short-circuited components. Capacitor checking. Step 1. Disconnect the power card. Step 2. Discharge the main large capacitor. Step 3. Test the healthiness of diodes and capacitors at secondary section using multimeter. Testing of diodes using multimeter. Set your multimeter to the diode test mode. Connect the multimeter probes to the diode terminals. The red probe should be connected to the anode of the diode and the black probe should be connected to the cathode. In the forward bias direction, anode positive, cathode negative, a healthy diode will typically display a voltage drop of around 0.5 to 0.7 volts. Reverse the multimeter probes like red probe at cathode and black probe at anode terminals. In the reverse bias direction, anode negative, Cathode positive. The multimeter may display OL, open loop, or a high resistance value indicating that the diode is blocking current flow. Testing of capacitors using multimeter. Set your multimeter to the resistance mode, ohms. Connect the multimeter probes to the capacitor terminals. Ensure that the positive probe is connected to the positive terminal of the capacitor and negative probe to the negative terminal. A healthy capacitor will initially display a low resistance value, which will gradually increase as the capacitor charges up. If the resistance value steadily increases and eventually stabilizes at a high value, indicating an open circuit, the capacitor may be good. If the multimeter reads a steady low resistance value or no reading, then the capacitor is faulty. Open the lead of capacitor and measure resistance using LCR meter. Connect the leads of the LCR meter to the terminals of the capacitor you want to measure. Ensure that the polarity of the leads matches the polarity of the capacitor terminals. Positive to positive, negative to negative. Apply the supply to board and check the output voltage without capacitor. If the output voltage is less or no output measured, then fault may be in capacitor. Switch off the supply and replace the capacitor with good one. Switch on the supply and check the output voltage. Record the observations in the tabulation. Measured output voltage without capacitor, with capacitor. Task 5. Connection of SMPS the circuit for performing load test. Step 1. Connect the circuit as per the circuit diagram. Step 2. Connect the 5 ampere moving coil ammeter in series with a 100 ohm by 2 ampere rheostat at the SMPS output as shown in the circuit diagram with correct polarity. Step 3. Connect a 20 volt moving coil voltmeter parallel to the circuit with the correct polarity as shown. Step 4. Connect the 240 volt AC power supply to the input side of the SMPS unit. Step 5. Power on the circuit. Step 6. By decreasing the resistance value in the rheostat, increasing the current in steps of 200 milliamps. Note down the corresponding voltage and tabulate the reading in the table. Step 7. Observe that even when the current is varied by the load, the output of SMPS remains constant at the rated voltage as in the graph. Recap. In this video, we have discussed how to identification the fault in short-circuited components using resistance method and isolation method. Identification of the short-circuited components. Connection of SMPS, the circuit for performing load test. Thank you for watching. Hi everyone, in today's video, let us learn how to connect battery and load to UPS and test on battery mode. Objectives. At the end of this video, you will be able to number 1. Measure the total voltage of the battery stack using voltmeter. Number 2. Connect the UPS and load test the battery. Let us collect the tools and equipment required to do this practical. Trainees toolkit 1 set, safety gloves 1 set, voltmeter 0 to 500 volt 2 numbers, digital multimeter with probes 1 number, UPS of 5 kV ampere with battery stack 1 set, double-ended spanner 10 mm 1 number, 100 watt by 230 volt test lamp with holder as required. Procedure. Task 1. Measurement of the total voltage of the battery stack using voltmeter. Safety precautions. Electrical hazard. Do not make contact with both of the battery terminals simultaneously, like screwdrivers or spanners. Sparking may occur during connection of battery cables, which may burn the skin seriously. Step 1. Ensure that the UPS is turned off and unplugged from the power source. Step 2. Disconnect the battery stack from the UPS and remove the cable from the battery. Step 3. Disconnect the cables connecting the battery stack to the UPS. Typically, these cables are connected to terminals on the battery and may be secured with nuts or bolts. Use spanners to loosen and remove these connections. Step 4. Prepare labels serially from 1 to N and paste them on each of the batteries. Step 5. Connect the DC voltmeter 300 volt across battery stack. Connect the positive lead of the voltmeter to the positive terminal of the battery stack. Then, connect the negative lead of the voltmeter to the negative terminal of the battery stack. Note down the voltmeter readings. Voltage across battery stack. Step 6. Note down the first label of the battery stack. Step 7. Set the multimeter for DC voltage measurement. Place the multimeter probes on the individual battery in the battery stack, like the positive terminal of the multimeter to the positive terminal of the battery terminal and the negative terminal of the multimeter to the negative terminal of the battery as shown. Step 8. Measure the voltage of the battery and note down the observed voltage. Measure the voltages of all batteries connected to the stack. Serial number 1. Label number. Battery 1. Measured voltage. Remarks. Number 2. Battery 2. Number 3. Battery 3. Number 4. Battery 4. Number 5. Battery 5. N. Battery N. Total voltage of stack. Step 9. Calculate the total voltages of the battery stack by adding each battery voltage recorded in the tabulation and ensuring that the calculated voltage is equal to the entire battery stack when measured with the voltmeter, if all the batteries are connected in series. Task 2. Connection of UPS and load testing of the battery. Safety precaution. Number 1. Before connecting the battery to the UPS, verify the electrode terminal symbol or color codes on the battery. Number 2. Ensure that the UPS is kept in switched off condition. Number 3. Connect the leads with correct polarity and tighten them. Step 1. Check the battery voltage. For 12 volt battery minimum voltage from 9.5 volt to 12 volt. Set the multimeter in DC voltage measurement with appropriate range. Connect the positive terminals of the multimeter to the positive terminal of the battery. Connect the negative terminal of the multimeter to the negative terminal of the battery as shown. Step 2. Connect the lamp load terminals to the output terminals of the UPS. Step 3. Switch on the UPS. Make sure the UPS is not connected to the input mains. Step 4. Switch on 100 watt lamp at the variable lamp load. Start the stopwatch and record the readings in the tabulation. Step 5. Keep monitoring the multimeter. On the display of the multimeter, you will see the voltage of the battery decreasing and halt the stopwatch when the lamp in the UPS glows with a beep sound, indicating the battery low. Serial number 1. Inverter status on. Battery voltage 12 volt. Connected load 100 watts. Stopwatch start timings. Stopwatch end timings. Step 6. After noting down the reading, immediately charge the battery using the battery charger unit. Step 7. After battery is charged, measure its voltage using multimeter and increase the load up to 200 watts from the variable lamp load. Start the stopwatch and monitor the display of the multimeter. Halt the stopwatch when the battery voltage is lamp in the UPS glows with a beep sound indicating the battery is low. Serial number 1. Inverter status on. Battery voltage 12 volt. Connected load 200 watts. Stopwatch start timings. Stopwatch end timings. Step 8. Switch off the UPS. From the tabulation, you will notice that the back time of the battery is decreasing as the load on the UPS is increased. As the load increases, the runtime decreases because the battery is being discharged at a faster rate to meet the higher power demand. Recap. In this video, so far we have discussed how to measure the total voltage of the battery stack using voltmeter, connect the UPS and load test the battery. Thank you for watching. Hi everyone. In today's video, let us learn how to open top cover of a UPS. Identify its isolation transformers, the UPS transformer and various circuit boards in UPS. Objectives. At the end of this video, you will be able to identify the major section in computer UPS. Identify the components used in computer UPS. Let us collect the tools, equipments and materials required to do this practical. Computer UPS 650 volt ampere 1 set. Trainees toolkit 1 set. Procedure. Task 1. Identification of major sections in computer UPS. Step 1. Unplug the UPS unit from the power source and disconnect any connected devices, including the computer, monitor, and peripherals. Make sure the UPS is turned off and there are no active power sources connected to it. Step 2. Remove the screws that are present in the side panel and open the UPS unit. Step 3. Once the enclosure is open, locate the battery section inside the UPS unit. Unscrew the battery clamp, pull out or remove the battery terminal connectors and take out the battery. Before opening CPU case, touch cabinet outer cover to discharge ESD power. Step 4. Note down the wirings and carefully lift the circuit board. Step 5. Find out the major section in UPS and note down the observations. Serial number 1. Major sections in UPS. Microcontroller. Description. The microcontroller is responsible for controlling the overall operation of the UPS. It oversees functions such as input power monitoring, battery charging and discharging, inverter operation and load management. Number 2. Transformer. The input transformer in a UPS unit is responsible for isolating the UPS from the input power source, such as the mains utility power. It steps down the voltage from the main supply to a level suitable for further processing within the UPS system. Number 3. Battery. The primary function of batteries in UPS systems is to provide backup power when the mains utility power fails or experiences disturbances such as voltage sags, surges or outages. Number 4. Switching circuit. The switching circuit controls the operation of the inverter, which converts DC power from the battery into AC power to supply connected loads during a power outage. Task 2. Identification of components used in computer UPS. Step 1. Before removing the circuit board, take note of any cables, connectors or wiring harnesses attached to it. Carefully disconnect these cables and connectors from the circuit board. Step 2. Identify the listed components in the circuit board as shown. Serial number 1. Name of the section. Stabilizer section. Components, parts or devices. The stabilizer section of a UPS uninterrupted power supply typically includes various components to regulate and stabilize the output voltage. Voltage regulator IC, transformer, filtering components like capacitors and inductors are components of stabilizer section. Number 2. On or off relay. When the UPS is turned on, the on or off relay is activated to allow power to flow from the UPS to the connected devices. Conversely, when the UPS is turned off, the on or off relay is deactivated, cutting off the power supply to the load. Number 3. PWM IC. A PWM IC generates pulse width modulated signals to control the switching of power transistors in the inverter circuit. By varying the width of the pulses, the PWM IC regulates the output voltage and frequency of the inverter to match the requirements of the connected load. Number 4. Control section. The control section manages the inverter circuitry responsible for converting DC power from battery into AC power for the connected load. It controls the switching of power transistors or other devices in the inverter to regulate output voltage and frequency. Number 5. Buzzer. One of the primary functions of the buzzer is to notify users when there is a power outage. When the UPS switches to a battery power due to a loss of utility power, the buzzer may emit a continuous tone or series of beeps to alert users that the power supply has been disrupted. Number 6. Switching devices. UPS systems need to convert power from one form to another to fulfill their function. Switching devices facilitate this conversion process, like converting the DC power from a battery to AC to load. Modern switching devices such as MOSFETs and IGBTs offer high efficiency and fast switching speeds, minimizing power losses and improving overall UPS efficiency. Number 7. Rectifier. In a UPS system, the rectifier is a critical component responsible for converting alternating current AC input power into direct current DC. The rectifier section consists of diodes and capacitors. Number 8. Fuse. Fuses are often placed on the input side of the UPS to protect against overcurrent originating from the utility power source. These fuses safeguard the UPS and connected loads from excessive currents that may result from short circuits, overloads or other faults in the external power supply. Number 9. AC auxiliary input. The AC auxiliary input in a UPS unit refers to an additional input port that allows the UPS to be powered by an external AC power source other than the primary utility grid. Recap. In this video, we have discussed how to identify the major section in computer UPS, identify the components used in computer UPS. Thank you for watching.
Namaskar and a very good morning. I am K.K. Mishra from Ministry of Power, Government of India, and I am here to discuss and talk about the various initiatives taken by Government of India, Ministry of Power regarding digital initiatives.
In a few minutes, I will be briefing